Okay, share the screen. All right, so now, as I said, you guys can go ahead and start doing this on your own. Probably the best thing to do, I would think, is to just use the old script, like the PyTorch code that we used last week, and then just add it kind of at the end. So I'm going to leave this one open, and I'm going to go to the old one, Regression Linear PyTorch. I think this is the one, right? So I'm going to open this one because this already has the data probably in the correct format. And so that, all I need to add here is XGBoost, right? So I'm going to do that. All right, so now we're going to take our wine quality data. We're going to try to predict quality, but we're going to use XGBoost, which is a regression tree, and try to establish what the R-square might be on this, right? And like I said, you guys do this on your own if you'd like, and if you finish before me, please let me know what the R-square is. So I'm just going to copy, I already have a lot of these libraries in here, right? So I just need to copy XGBoost in there, really. I'm going to do a new cell here, XGBoost. Okay. I'm gonna save this and I'm gonna clear the kernel and just start over. All right. I go ahead and run the libraries, make sure I have everything I need working here. Okay. And run XGBoost. All right, so great. So I've got all the libraries. Let's take a look at the Boston example. So basically we load the data and we just need to know what X and Y are, right? In our train and then do our train and test split basically. Okay, so let's get to that part. Now, when we did X train test split is sklearn, so it's coming out as a NumPy array, so we're good. We don't need to convert this into torch tensors because XGBoost does not need torch tensors, right? NumPy should be fine. So let's go ahead and do that. I'm going to hit. Okay, so we read the wine quality data, we print it out. We do the correlation matrix. Sure, why not? We are going to convert it to NumPy, split it into X and Y. We should, that's consistent. We've got our data there, and then we do train test split. So, okay, so now they have been divided. So we can print out the shapes. And we've got the float 64 should not be an issue with XGBoost. Although you can change it to float 32 if you'd like. And then just remember, we conveniently use the extension _tr to indicate if something is a torch tensor. So when we use XGBoost, we're just going to use these names instead. Okay, the X train, so on. All right. Although you don't really need to even run this cell here. All right. So now what we can do is let's just go to the end. We can skip from here. We already have X train, all these variables created, right? So now we can jump pretty much, skip all of this. And in here, let's just add a new cell, a few cells. And I'm going to call this XGBoost. And let's see what we get. So let's run it. So now we can pretty much copy, I think. Right, so I'm just gonna copy that code as we used it in the Boston example. So this create the regressor. Okay, everyone with me? Okay, hit run. Then we're gonna do the fit of X train, Y train, right? I can copy that code as well because this is pretty consistent. Okay, hit run. All right, no errors. That's good. That's a good sign, right? Our model should be trained at this point, but with the wine quality data, right? The wine quality data. All right. What else? Well, let's predict, right? Questions? Okay, let's go ahead and predict. So I'm just going to copy this one, right? Should be like that. Hit run. Okay, good sign, no errors. All right, so let's now do YPred shape just to get a feel for what the dimensions look like. 980, that's what we should have in the test set. We can also take a look at YPred itself. Okay, looks like ratings, right? It looks like ratings. And now the R squared. Okay, so we're gonna run basically this, right? And let's see what our XGBoost gives us. So that's Y test, YPred. So I believe it's correct. 0.36. All right, so that's what we got. 0.36. It seems like this is a hard problem. So like I said, I didn't look at this. Now the random forest gave us a really good result, right? So an XGBoost was not able to give us so I would have given all of this, what I would say is that the performance of this model can be between 0.36 and 0.54. And so that's it. So you can't really, we've thrown at this almost everything we've got. Now, this was only, now granted, this is not necessarily apples to apples. Yeah, go ahead. You got 0.43. Why is that? We did tenfold cross-validation in Weka. That means I did this 10 times. And the average of that was 0.54. Here, I only did it once. I got 0.36. You got what? 43. So the average of that is like 0.39. Do you see that? So really, this is a good point to compare this experimentally correctly to what we did in Weka. We should do this 10 times and take the average of that. And that is a more correct number. You guys see that? Another thing that you can do is sklearn does have a regression tree. So that's like the last tool that we have to also throw at this problem. How about the rest of you? Did the rest of you run this? And did anyone get more? You got 0.43, which technically is the highest value except for Weka that we've achieved, right? So anyone else get something else?
Yeah, 0.44.
Okay, so you now are the lead, 0.44. Anyone else? You got 0.45. Okay, so 0.45. Do you guys get so obviously XGBoost has now beaten our neural networks, right? Because I think our neural networks had only gotten to 0.4. and we've got a 0.45, a 0.44, a 0.43, that statistically to me means low 40s. Another great thing is we can deploy XGBoost, right? Weka is more of a prototyping thing, but XGBoost we can deploy. So it's a model you could make available to do actual inference, right? And I'll show you guys how to do that with Onyx runtime, because we're going to deploy these models, okay? Do you guys understand how this works? So in conclusion, right, what are the conclusions that I would say we have so far? We're solidly in the 40s, right? Low 40s with XGBoost. We did get that regression tree at 54. If we wanted to deploy it, we can look at sklearn's regression. I just don't have the code for that. I didn't think of trying that out. So maybe for next week, I'll try it out and see what I get on that one. Or you guys feel free. It's very easy to implement a regression tree in sklearn. So try it out. But yeah, that's kind of it. I mean, we've achieved some score. And now, could you achieve 0.44 with neural nets? Sure. Just try different architectures, play with it. That's the whole point of this, right? So imagine this was a competition for hypothetical $1,000. You'd be motivated, right? To try, to try different models to win the competition. All right. So what I will do, as I said, is I will print a PNW mascot lion thing, and this big, and I will bring one of those, whoever gets the highest score, and I will give you this as a trophy. All right. So for your homework. So do your best. But yeah, that's kind of where we are. I wouldn't expect anyone to get higher than 0.54, given the information that we have. But I would certainly say anyone that submits a homework of 0.27, you just didn't even try, right? Because you should be able to get in the low 40s for your assignment. Got it? Now, definitely try a neural net and then compare it to maybe XGBoost, okay? And just provide those two scores. Okay, see that this is what I'm saying. So this is really solidly statistically significant. 42, 44, 43, 45. It's low 40s for sure, right? And so that's good. So definitely XGBoost is, living up to the hype, since it's like the second just behind Random Forest for that Weka example that we did. So I'll run it one last time here. Now you may want to normalize the data and then run XGBoost, see if that gives you even better performance. That's something else to try. I mean, it's just, it's the nature of machine learning, basically. Okay, so that's done. Gonna read the data again. Okay, now I'm gonna go down here. All right, I'm gonna run XGBoost one more time. Now notice XGBoost has these parameters there. Do you see those parameters? That's another thing. I didn't actually look in Weka to see what the default parameters were. It's possible that Weka had better. Notice the max step is only 3, maybe 4, right? 2, play with the parameters. Definitely that could help, okay? So let's run it again. 0.42 this time, 0.43 actually. So just like some of you, right? And so, yeah, we want to push that, right? We're definitely away from 0.27 where we were last week. We've made some progress. This would be a good model to me, it seems, and yeah. All right, the last thing that I'm going to mention today. Oh, yeah, please. Yeah, go ahead, Linda, please.
Could XGBoost take 1051 or two with that performance, or should we have it feed NumPy?
NumPy, use NumPy, because the torch tensors are for PyTorch, so that's like a specific data type of torch. It's more of like a data structure. All right, so yeah, so 43%. So XGBoost, as I said, if you read the literature and everything, it does really well. It might have one downside, and that is called the extrapolation problem. So what that means that it doesn't extrapolate well to values outside of its ranges. You know what I mean? Like if it trained on, let's say like pH, I don't know what pH goes from, but let's say pH balance from 1 to 5, and that's the range. If you were to give it a 0.7, which it never saw, it may not do as well. And that's called the extrapolation problem. It doesn't extrapolate well to values outside the ranges that it has seen before. Whereas neural networks are good at that. Do you see what I'm saying? So it could be a situation that even though XGBoost has better R-squares, in the end, if the neural networks are also good, you may prefer the neural networks just because they extrapolate better, right? So if your goal is actually to predict values that you've never seen before outside of ranges, then neural net might do much better. They're better at that. Whereas XGBoost, because of the nature of how it is, it's not, it's making decisions, right? And if it's never seen that, if it's a value outside the range, it may not extrapolate well. So the performance will be affected. But if it's within, like if your data is, the things you're trying to predict are within what it has seen before, then it's okay. That's, because it's not extrapolation. That's the only downside that I'm aware of, and is well documented in the literature. But otherwise, yeah, it's for a lot of competitions where it's like this, it gets pretty good results. Got it? All right, so are there any questions? This would conclude the XGBoost discussion. As you can see, it's, well, the demo, so you can see it's pretty easy to use. It's a complicated algorithm though. And so we'll take a look at that next week after the theory of it. Okay? So I'll do a lecture just on regression trees in general, leading up to XGBoost, and kind of give some intuition. We may not implement this in code, though. It just doesn't make sense because it's quite complex. All right, so I'm going to pause the video.